Hello everyone. Whenever converter is used for giving power or delivering power to a load, it is required to know how the converter is to be operated. That means what will be the firing angle. Here it is discussed that how to find the firing angle of a single phase converter when it is driving a DC load. In case it is considered a DC motor. It could be easy to understand the topic if we take an example and try to understand the process through this example. Uh, we are moving forward to a example. Let's say a 220 volt, 1400 rpm, 40 ampere separately excited DC machine has an armature resistance of 0.4 ohm and the motor is fed from a single phase converter with an input AC voltage of 220 volt RMS. Now we need to find out the firing angle of the single phase converter for motoring operations at 50% of rated torque and 1000 rpm speed. So in this case there are two type of problem is there. First, it is required to find out the load requirement in terms of voltage, and then it is required to match with the output of the single phase converter so that it can operate the load as required. First, the DC machine part is focused to find out the load requirement. Here it is considered uh, the rating of the machines as a case 1 or condition 1, and at which condition it need to be operated, that is considered as case 2 or condition 2. First of all, it is a separately excited DC motor, so the torque is directly proportional to armature current. So it is expressed as T proportional to IA. From this relation, it can be written as that T1 by T2 equals to IA1 by IA2. Now, if condition 1, that means rating, and the condition, that means case 2, is correlated, then it will be T2 and equals to 0.5 of T1, and in case 1 current is 40 ampere. If we put this value, it will finally give the case 2 armature current, that is 20 ampere. Now it is required to move forward to calculate the terminal voltage. terminal voltage equations of a DC motor is given as Vt equals to EB plus IRA, where Vt is the terminal voltage and EB is the back EMF, and the rest part are denoted as standard form. If we put the value as mentioned in example, then we can find out the back EMF, and the value of back EMF will be 204. This is the case 1 back EMF. And now the second portion of the case 2 or condition 2 is speed. We know that the EB, that means back EMF, is proportional to speed. So the relation can be given as EB1 by EB2 equals to N1 by N2. Now, if we put the value of the example for the case 1 and case 2, then we can find out the EB2 as shown here, and finally it will come that EB2 is equals to 145.712 volt. Now it is required to find out the terminal voltage for the case 2. The equation will be same, that Vt2 equals to EB2 plus Ia2 Ra. Now previously it is calculated that EB2 equals to 145.712 volt, and current is 20 ampere, and the rest value are given and mentioned in example. If we put their value, then the terminal voltage Vt2 will be 153.712. Now first portion of load requirement is done. Now it is required to focus on the converter side. Let's understand how the waveform will look like. They are shown in this figure. The red one is showing the input voltage or supply voltage, and the blue one is showing the supply current, that is IS. Sorry, here it is written as IO, but it will be as IS supply current. The supply current, as the load current is not fluctuating or changing, it is a constant DC current. So the nature of source current will be like the blue waveform. For the period of alpha to pi plus alpha, the thyristor T11 and T12 will operate for the positive half cycle, and for the period of pi plus alpha to 2 pi plus alpha, the thyristor T13 and T14 will operate. As the current is going through the thyristors for the given period from alpha to pi plus alpha and pi plus alpha to 2 pi plus alpha, so the waveform of the output voltage will be as shown in green line of the waveform, and the average of the output can be calculated as V0 average equals to 1 by pi integration over alpha to pi plus alpha Vm sin omega t d omega t, where Vm is the maximum amplitude of the supply. Now, if we calculate the average voltage, it will, that means if we done the integration, the result will be V0 average equals to 2Vm by pi cos alpha. This output voltage should be equal to the terminal voltage of the DC motor. Then only the converter will be able to run the motor as mentioned in example. So the output voltage should be equals to terminal voltage. Terminal voltage is calculated as before, that it will be equals to 153.712, and then if we put the value of maximum amplitude of the input, and then if alpha, that means firing angle, will can be calculated, and it is shown here. This is the procedure how the firing angle will be calculated for a load requirement. I am just summarizing the process. First, it is required to calculate the load requirement. Then it is required to calculate the output voltage of the converter by taking the firing angle as a variable, and then we need to equate those two things to evaluate the value of firing angle. If anyone finds any further queries, please do comment and it will be answered. Uh, if you like the video and enjoy the thing, then please do like, comment, share with your friends, and do subscribe and turn on bell notification for any further updates. I am Arindam Das, signing off.